So I want to welcome you guys back to another beautiful day here in western Oklahoma. We're at the Grit and Gravel Greenhouse today, and I'm going to show you how we have our fish tank set up here for our aquaponics system. So we have 4 fish tanks in this system. They're 200 gallons each, and all of them hold 100 catfish each. So we'll start with over here with tank number 1. And what we have here on tank number 1 is the line coming in from the sump tank, going up and teeing off in a valve that I'm adjusting the flow rates between tanks 1 and tank 4. Now this line that tees off goes over and feeds tank number 4. Now all these tanks also are tied together with a 3/4 inch drain line. Each one of these tanks has the ability to flow from one tank to the other through these lines. So we'll look over here at tank number 4. So we have the water coming in on tank number 4 at a 45-degree angle. That's giving us our swirling effect, which makes this just a large swirl filter, which is driving all the solids to the center and then being lifted out through this solids lifting outlet. So the way we have tanks 1 and tank 4 are identical, and tanks 2 and tanks 3 are identical, which on tank 3 we have a solids lifting outlet, but the level in tank 3 is just a little bit lower than the level in tank 4. And what that's doing is giving us the ability to use the weight of the water to push out from tank 3 to 4, and that's how we're feeding tank 3. Now we do have the same effect in here. Here's the inlet for tank number 3 coming from tank 4. And it's sitting at an angle and giving me that swirling effect. Now the only difference between really tank 3 and tank 4 is the height of the water and the diameter of the solids lifting outlet. So tank 1 and tank 4 have a 3/4 inch solid lifting outlet, and tanks 2 and tank 3 have a 1 inch solids lifting outlet. So that makes sure that I don't have too much water leaving tank number 1 and number 4, and that I'm pushing a sufficient amount of water over to tank 3 and tank 2, and then that water is being carried out through a 1 inch, and that is sufficient enough to give me the drainage I need to hold the level in tank number 3 and number 2. So the level is not ever going to get up any higher than what this standpipe is, because I have the capacity to move the water out faster with this 1 inch than I do with the 3/4 here on tank 4. So if we get down here and look, you can see the shadow line of the water here. You see there's about a 6 or 8 inch difference in the height, and that is purposefully done in order to correctly flow the water over here and get the flow rates right on tanks 2 and 3. So you can see tanks 2 and 3 are almost identical in height, and tank 1 is going to be the same as you've seen on tank 4. So the reason that we set these up this way and we equalize these tanks is to protect the fish. And we have a lot of thunderstorms in the springtime here in Oklahoma, and we lose power during those storms a lot of the times. And if we ever happen to lose power to these pumps at night or something, or when we're at work or not around, then we know that we can protect our fish with these solids lifting outlets not allowing the water to drain any lower than the lowest point. So if we have an outage, then tank number 4 and tank number 1 will drain down, but they will only drain down to the level of tanks 2 and 3. They will not get any lower due to the height of the solids lifting outlet in tanks 2 and 3. So that way we have a little bit of time, if we don't happen to be here when it happens, to rectify the problem. We do have a little bit of time to save these fish when or if we have a power outage. So there's a little look at how we have our fish tank set up there. We'll go through in another video and I'll explain how we have the header that the tanks are draining into, and how we are feeding and flowing water to our grow beds from our fish tanks. So I want to thank you guys for watching today, and we'll see you next time.